Here's the next review video for the semester exam. Determine if the relationship is linear or nonlinear. Okay, some of these are very, very easy. If it's linear, it fits the pattern y equals mx plus b, or something similar. You do not want any exponents of 2 or 3, etc. Okay, so this one, you have an exponent of x. Definitely not linear. This one, you have an exponent of 2. Not linear. This one, y equals mx plus b. It's just in a different order. This one is linear. This one, same thing. Y equals 4x plus 5. That works. I also want to point out, you can put these straight in the graph screen of your calculator to see if it makes a line, and you'll know if it's linear. These, all of these, you can do regression in the calculator as a last case scenario. I'm going to show you a quicker way, but if you need to do regression in the calculator and put all these in a table in the calculator and then see what the line it would make and find the equation, that is a way to see if it's linear. Let's go ahead and just pick one. I'm going to show you a more straightforward way based on what we learned earlier this year. So we have the point 5, 3, 6, 5, and 7, 7. I rewrote those because I don't want to look at it straight across. I want to have my x's together and my y's together. Alright? What you're looking for to see if it's linear, you're looking for a constant rate of change, or just constant rate. The rate is your m number. You want the m number to be the same every time. So what do? You see how your y is changing? They call that your change in y over change in x, or they call it your rise over run. These are all things that we've called it. Okay? All of these things. Change in y over change in x, rise over run, etc. So how is my y changing here? From 3 to 5, it went up 2. From 5 to 7, it went up 2. 5, 6, and 7, it went up 1. 5 to 6. 6 to 7. What I look at is my y changing number over my x changing number. So if I get the exact same thing every time, or if it reduces to the exact same thing every time, it is linear. So this one is linear. So you can do these two on your own to see if they are linear. Okay, this next section. Write a function rule for each situation and answer the question that follows. Okay, so a function rule is basically just, for our purposes, it's something like this. Okay, everything we've done all year is linear, so it's going to be something similar to this. The price P of the ice cream sundae is $3.75 plus $1.40 for each topping T on the sundae. What is the price for a sundae with 3 toppings? Okay, this is the question. So we don't need anything from this sentence to get the equation. For our purposes, we have a one-time value and an over and over value. Well, what are we paying only once? This initial price is only once. What are we paying over and over? $1.40 for each topping. So every time we buy another topping, we're paying the $1.40 again. That's my m number. So this is our equation. The cost of the sundae is equal to $1.40 times the number of toppings plus $3.75. So if I want to find out how much it costs for 3 toppings, which is what they're asking me, I'm going to put $1.40 times 3 and then plus 3.75. Okay, so there we go. Let's see what we get. $7.95. Okay, let's move to the next section. For each representation, determine the values of domain and range. Remember, domain is x values. Range is y values. We learned about Dixie and Roy D. Dixie Roy D. Dixie is domain, input, x-axis, and independent values. Okay? In fact, I suggest that you, even on your test, you jot this down on a piece of paper to refer to. So there'll probably be several times on this review where we're going back to Dixie and Roy D. So, domain, input, x-axis, and independent values. Range, output, y-axis, and dependent values. Okay, we're going to go back to that here and there. Okay, state whether a function exists and explain why. Remember, for it to be a function, the x's can't repeat. X's cannot repeat. And we can also test it by doing the vertical line test, okay? So number 3 is not a function because right here, those x's repeat. It fails the vertical line test. Okay, what repeats? It looks like the x value of 1 repeats. There are 2, x equals 1. There are 2 places where x equals 1, okay? Now what's the domain? The domain for this is you just get all of the x values. Okay, so let's go ahead and do it now. So here I have, what I'm going to do first, I'm going to go ahead and write all of the ordered pairs. I'm going to do that way over here on the right. You'll see why. Because here I'm just finding ordered pairs. But then everything in the left is my domain and everything in the right is my range. Okay, so negative 1, 2, 3. So I have negative 2, 1. That's this guy. Negative 3, 1. That's this guy. I'm marking it so I know I already put it in there. 0, negative 2. 1, 2, and 1, 3. And 2, 4, negative 1. And that's all of them. All right? So when you list the domain, you put this in order from smallest to biggest. This is my domain. And here you see the repeating x's again. Okay? And then this I would list from smallest to biggest, and this is my range right here, those values. All right? Let's move on. Let's go ahead and do this one. This is a mapping. So what is the domain? It's everything on the left. We have negative 3, we have negative 2, we have negative 1, and we have 0. The range, we have 12, 13, 14, 15. Now, is it a function? Are there any repeating x's? It's not listed twice, but is it being used twice? This negative 2 is going to the 13 to make that point. It's also going to the 15 to make that point. So it is not a function because negative 2 repeats. The negative 2x value repeats. Okay? Let's go to number 5. State whether the following representations are functions or not. Okay, well, if there's a repeating x anywhere, it's not a function. Here, not a function. I put a vertical line here. All these x values of 4, we have a bazillion x values of 4. You cannot have a repeating 4 for x. So that's a no. This one is a yes because vertical line test is okay. This one's a no because look, it fails the vertical line test. We have all these repeating x's. This one, you look for the x's. 5, 4, 3, this one's okay. 4, 4, 4, those x's are all repeating. This is not okay. 3, 7, 3, the 3's are repeating. That is not okay. Next section. Use the functions f of x equals 3x minus 5 and g of x equals 10x plus 5 to find the value of each expression. All right. Let's do 1. Actually, you can easily do all of these in the calculator. And I really want to show you, because that's the best way to do these, but I'll show you one without the calculator. Okay. So, g of 8. First of all, what are they giving me? They're giving me an x value in this situation for the g equation. All right? If it said g of x equals 8, they'd be giving me a y value for the g equation, okay? They're giving me the input because it's been input into this parenthesis, all right? So I'm putting an 8 right here, okay? 8 times 5 is 40, plus 10 is 50. So g of 8 is 50. That's the answer. That was pretty easy. Let's see if there's, oh, these down here are a little more complicated. Let's show you how to put it in the calculator. The same one that we just did. So I go ahead and I'm going to go to my graph screen. And I want to clear out everything, okay? So when I do Doc B, it clears out everything. Make sure everything is cleared out. It is. All right. In my graph screen, I type in both of these equations. F of x equals 3x minus 5. Okay, so f of x equals 3x minus 5. Enter. There's my line. Hit tab. Now I'm going to put in, instead of f2 of x, I'm going to change it to g of x equals 10 plus 5x. 10 plus 5x. Ready? There's my other line, okay? Now, keep that in there. Go to your calculate. Now watch. If I put in g of 8 right here, g of 8, it just told me what I had to calculate by hand just a second ago. It's looking at the graphs on the other screen, and it just calculated what g of 8 is. It just told me, okay? I can do all of these this way. I can do f of negative 4. F, parenthesis, oh, I almost made a mistake. I hit minus. It's not minus 4. It's got to be the negative sign 4. Okay, hit enter. It is, hold on. F of negative 4. Well, I thought I would be able to do it this way. The function is defined. Let me go back to here. Oh, it is my fault. See, it's F1. Let's rename this. It's F1 of x. It should be f of x. So I'm going to get rid of the 1. And I'm going to clear that out, and now I go back to my calculate. Okay, let's copy and paste that. Negative 17. All right, so when you get to these complicated ones right here, you just type in f of negative 4 plus g of 2. All right, let's do that. I'm going to copy and paste, Control C, Control V. F of negative 4 plus g of 2 plus g of 2. There you go. That's how you get these. Now let's do one. Let's do one by hand, just real quick. So we have f of 7 minus g of 2 right here. We have to find f of 7, meaning this is an x value for the f equation. So if I plug in 7 here, 7 times 3 is 21, minus 5 would be 16, so that's a value of 16. G of 2 would be an x value of 2. 2 goes into the x in the g equation right here. 5 times 2 is 10. 10 plus 10 is 20. So you get 16 minus 20, and that gives you -4. All right? That's how you do it, and if you're comfortable with that, it's very easy. But even if you're not, it's still very easy right here. Let's go ahead and do f, just to check it. F of 7 minus g of 2. G of 2. There's our -4. So there we go. All right, we did several on these, so I'm not going to do this one. We did a lot in that section. Section 3.1. Use the given information and your knowledge about rates to answer the questions that follow. Jose can run 12 miles an hour in 1 hour. Stanley can run 1 mile in 6 minutes. Maria can run 3 miles in half an hour. Who runs the fastest? Who runs the slowest? Okay, on these, it's all about getting a standard rate, okay? We talk about miles per hour, not miles per minute, not miles per half an hour. So we need to convert all these to miles per hour. When we have a standard rate, we can see who's faster or slower. So Jose is 12 miles per hour, all right? Stanley is 1 mile in 6 minutes. We have to convert that. Okay, how can we convert that? There's a few different ways. One way is just using a proportion that you learned from middle school. If he's running 1 mile in 6 minutes, then how many miles is he running in 60 minutes? Because that's how many minutes are in an hour, right? So we have 60 times 1 is 60, then divided by 6 is 10. It comes out to 10 miles per hour. All right? Another way, if you didn't think of this or you don't like this, we're doing I'm trying to think. That's really the easiest way I can think of offhand. If I think of another one, I'll come back to this. Maria can run 3 miles in half an hour. All right? 3 miles in half an hour, well, that's, if we doubled this to get an hour, we would double this to get 6 miles in an hour. Okay, so fastest, Jose. Slowest, Maria. Easy enough. Okay, that's how you do those. Let's go to the next one. Determine the slope from the given information. So, this one's a special case. It is a no slope, undefined. Okay? Also keep in mind, this one, if there's not one on here, but if they had one, this is a 0 slope. Okay? This is a positive slope. Let's find some friendly points and let's figure out the slope. So we have a friendly point here and here and here. It's going up 1 over 3, up 1 over 3. So my slope is 1/3. Up 1 over 3. 1/3. Sorry, there it is. This one is a negative slope. It's going downhill. So we find our friendly points. Down 2 over 1, down 2 over 1, down 2 over 1. It's -2 over 1, which reduces to -2. That's how you do those. All right, these, we already did an example of this. You find your change in y and your change in x. I'll just do one of these because we already did several. We did a couple on the other screen. It was under a different section, but it's the same premise. Okay, so from 16 down to 13, it went down 3. 13 down to 10, it went down 3. 10 to 7, it went down 3. So my change in y is consistent. My change in x is consistent. It's always going up 1. So we have a constant rate of change of -3 over 1, which is -3. Now keep in mind, if these aren't the same, reduce the fraction and it might be the same. If it's still not the same, then you do not have a constant rate of change. These are the same. You're just going to set them up like this. and then you do it just like we just did the last one. All right. What is the rate of change of the given situation? The population in Seguin, Texas in 1980 was 32,340 people. The population in 1990 was 48,590 people. Okay. I don't like that one too much, but well, I guess we'll do it. Let's go ahead. Excuse me for my cough. Okay. We have X is our date. Y is our population. Okay. So we have a date of 1980, population 32,340. We have a date of 1990, population of 48,590. It's really, in essence, just like the other ones we did, just bigger numbers. So here, what's my change in Y? It's going up. Let's figure out how far it went up by subtracting those two numbers. 48,590 minus 32,340. So it went up 16,250. This went up by 10. When you divide these, you get your rate. So this divided by 10, and you get that, 1,625 people per year. Like I said, I don't really like that, the weird thing using dates that way, but sometimes it is used that way. That's how you do it. Okay, determine the missing variable. So we know the slope, all right, and we have 2 points, but one of the points is missing a value. So here's what we can do. These were challenging on some of the homeworks. So we have x, 7 and 3, 11. Here's what we know. We know that my change in y over change in x is going to equal to 2. All right? 7, 8, 9, 10, 11. It went up 4. 4 divided by what is 2? 4 divided by 2 is 2. This number, this change in x, has to be 2. All right? Positive 2. All right? So this has to be 1. Because from 1 to 3, you have a change of 2. That change divided by that will give us the slope of 2. So x is 1. That's how you do those. All right, next one. This is getting to be long. I'm going to stop it after this one. Identify the slope m and y-intercept b of each line and then write the equation of the line. Okay, let's find b first for all three of these guys. Ready? B, right there. It's the y-intercept, -4. I'm just gonna say b is -4. Okay. B, right there. It's 0. B is 0. B, here it is, -4 again. When we're thinking of y equals mx plus b, we already have the b. Y equals something x minus 4. Y equals something x. And then there's just nothing there. We just know it's something x, and the b is 0. And this, y equals something x minus 4. All right? We know here the slope is 0 because there is no upward or downward motion. So this is just y equals -4. That is the equation for that. This one, let's go ahead and find some friendly points. We have a lot of friendly points. It's going up 2 over 1, up 2 over 1, up 2 over 1. Y equals 2x minus 4. This one, y equals this one looks a little bit off. It's a little bit, I think this is misprinted, because this one looks like it is right on. This one looks like it's right on, but that's down 1 over 5. And that's above. So I think there's a mistake here. Let's scratch that one out. Your test will not have that. All right. let's move on to the next video.